Hi YouTube, welcome back to the second part of the system design. Today we talk about the database. If you remember, in the first video we designed a single server, a single client server basically, and I'll just go give it a quick look. Actually, we had a client. This client could be mobile or web browser, and basically it communicates with the web server by domain name using a DNS we're using a DNS to send the domain name, and it will send us back the IP address of our web server. The client connected with the web server by HTTP request, and it requests, for example, JSON data or like a HTML page, and the web server will send to the client HTTP response. So basically, right now, let's assume that we had in our API. Let's just put this. We have. Oh no! Let's just make this one bigger. Yeah. Okay. We have in our API. We are asking for a GET request, and we are requesting the user. So basically, let's just assume that we have let's first say that we have let's make this white. We have a GET request. So basically we have a GET request under the name of let's say users /12, and let's say that 12 it's the ID of the user. Maybe we want to get the user ID, and let's just put this in a square. I guess it will be better if we put in a square. Okay, we make it wide. So basically, let's just make the square bigger. It will need to be big. It will need to be big, basically. So basically, we have let's say that the okay, and yeah, basically it's and let's say that we have this user maybe, and we expect basically to get our own user, which will be which will be for example maybe ID of 12, and it has a name that is equals Mo, and it has like age, for example, that it age that equals 30, let's say 12, no, let's say 44. Okay, and basically we are getting this data from the server. However, when let's say that our user is our user, basically it's getting bigger and bigger. So basically with the growth of the user base, basically the database, the amount of users that we are storing, it's getting bigger and bigger. So basically the growth of the user database, with the growth with this one, we need to store them in server. That server called a database. And a database is a structured collection of data that is organized in a way that allows for efficient storage, retrieve, and manipulate of the data. Databases are used to store and manage large amount of data access and also it offers a variety of and actually a lot of applications are using it. Like I guess all of the applications are using it. There is no application that I know that doesn't use database. So basically, database is just a server that it's a structured collection based database. It's a server and which is a structured collection of data of data that we can organize our data in. So, for example, it will be, let's say that we have, sorry, no, go back, delete, where is delete, yeah, and let's add a database, let's add it here, okay, and let's just data, and let's just add database and make it quite bigger. Okay, and okay, we have this database, but when we use database, basically database has we can use two options. We had like we have a SQL database and NoSQL database. Let's just me write this here. We had basically a SQL database and and um, and no SQL database. And basically, let's talk about what is the difference between them basically. So I will say that by default we will go with a SQL database. By default we will go with a SQL database because first of all it's been there like for more than 40 years and they have worked well, and they are quite faster to query from than the NoSQL. And also we have it supports the transaction, the ACID transactions, which stand for automaticity, consistency, and isolation and durability. That means that a transaction is all in or nothing. Okay, so basically the operations could fully succeed or could fully fail, and this is important if our application is requires a lot of consistency, like for example like a finance system, something like that. Also, it's good for complex query, like SQL is more suited for application that requires complex queries and data analysis. SQL supports basically a wide range of query operations, including joins, group by, and aggregation functions, which made it easier for us to use a query on a very complex dataset. However, there is some situation that it is better for us to use the NoSQL. Let's say first, if our own application requires super low latency. Second, if our own application requires really high availability. Okay. Third, let's say that if our own application requires to, we want application, we will have tons of data, like tons and tons of data, and we need to scale like horizontal. I need our application to be easy to scale, so we'll use the horizontal scaling. So it's a better solution to go with the NoSQL. And maybe we need we don't know actually our data has no relation. Actually, there is no relation in our data. Maybe other thing that we don't know how the structure of our data yet. So all of that things that we go with the NoSQL instead of the actual SQL database. And that's it for choosing our database. And seeing you in the next video, I will talk about the how we can scale our data. And yeah, that's it for today. See you on next video. And yeah, by the way, before I leave, before I leave, okay, if you like my video, make sure to subscribe and give it a thumbs up, and hit the notification bell so you'll never miss a video.